Algebraically, I'm going to need some paper. Give me just a moment. So algebraically, I'm going to use substitution. So I have y equals 2x plus 4 and y equals negative x squared plus 4. So since they're both equal to y, they are equal to each other. So I'm going to set them equal to one another. This is equal to this. 2x plus 4 equals negative x squared plus 4. Now to solve a quadratic, I would probably want to move everything to one side. So I'm going to start moving my squared term. I don't like it to be negative, so I'm going to move it this way. So I'm going to add x squared and subtract 4 from both sides of the equation. I get x squared plus 2x equals, over here is 0. The 4's canceled. And so now I'm going to solve by factoring because they have when c is missing, right? C is missing. It's easiest to just take out the GCF. So the GCF of x squared minus 2x is x. If I pull an x out, x times what is x squared? X times x. And x times what is 2x? 2. And then I set both equal to 0. And solve. This one's finished. There are my two solutions for x. But now remember, I'm looking for a solution to the system, which means an x comma y. So I have to find out y equals, and I have to find out y equals. So to do that, I'm going to take my 0 and substitute it into either equation. I'm going to pick the top one. Y equals 2x plus 4. So when x is 0, y is 4. Now I'm going to check it using my other equation. Y equals negative x squared, which was 0, plus 4. That cancels out. 4 equals 4. So here's my check. So I used the first equation to find y, and I used the second equation to check for y. So my solution is 0, 4. That means that these two graphs are crossing at 0, 4. All right, the next one, I have to do it again for this solution. All right, so I'm going to substitute into the top one. Y equals 2x plus 4. Y equals, that's negative 4 plus 4. Y equals 0. And then I'm going to check it using the second solution, or the second equation. So y equals negative x squared, and x was negative 2, plus 4. 0 equals negative, and then when I square this, it becomes a positive. That's negative times positive 4, which is going to be negative 4, plus 4. Be careful, right? When you square this, it becomes positive, and then we're multiplying by a negative on the outside. So 0 equals 0, check. So my solution here is negative 2, 0. That means that the graph crosses at negative 2, 0 as well. Now we need to do this graphically. All right, so we're going to graph both equations. The first one is a line, and the second is a parabola. Now I know that because the first one, the highest degree, right? The highest degree is a 1, and here the highest degree is a 2. So to graph the line, y equals 2x plus 4. This is my y-intercept, and this is my slope. So that means I'm crossing at 4, and then my slope is going up 2 and right 1, or down 2 and left 1. Down 2 and left 1. Right there. There is the graph of my line. My quadratic, it has a y-intercept of, well, let's go back to this. Y equals negative x squared plus 4. This is my y-intercept, C, right? And this is my A. So this is just a reflection of the parent. So I'm going to take my parent function. This is telling me to shift up 4 and to reflect. So I'm going to take my parent, which is at 0, 0, 1, 1, right, and negative 1, 1, and then it would be at 2, 4, and negative 2, 4, and positive 2, 4 right here. And I'm going to reflect that graph. So that means that this point will be right here and right here. Those are gone. And that this point will be down here, and this point will be down here. And those are gone. Now I'm going to shift this graph up 4 units. So that means that this point will move up 4. 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 And this point will move up 4. And my quadratic will look something like that. Now to verify, they are crossing right here. That's at the point 0, 4. Boom, it's amazing. And the point negative 2, 0. Amazing. All right. The next one, I need some more paper. Hang on. All right, the next one. Solve algebraically. 3x minus y equals 2, and y equals negative 3x squared plus 4. All right, so this guy, we're going to need to move the 3x over because I need to get it in slope-intercept form. So I need to get y equals mx plus b. So I'm going to move the 3x. That would give me negative y equals negative 3x plus 2, and then divide everything by negative 1. That gives me y equals 3x minus 2. So when I go to graph this, right, don't forget when I go to graph this, my y-intercept will be negative 2 and my slope will be positive 3. I think I'll do graphing first this time, since I've already started to get this in slope-intercept form. All right, so my y-intercept is down here at negative 2, and my slope is up 3, right 1. Now I'm not using graph paper, so it might be a mistake to try to start with graphing, but we're going to try it out. And then I would also go down 3 and left 1. And there's my line. Okay, next, to graph my quadratic, this means that I'm shifting up 4. That's also my y-intercept, by the way. And that I'm scaling by 3 and reflecting. So what's going to happen is I'm going to graph my parent. I'll do that in blue. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now I'm going to scale by 3. That means my y values are going to be 3 times as large. That means that these values are going to be way up there at 12. I'm just going to pretend, like mock them up there. They're at 12. These values are at 1. They're going to be 3 times as large. 3 times 1, like, oh, the reason that was 12 is 3 times 4 is 12. 3 times 1 is 3, so those will be up there. And 3 times 0. So you notice how much skinnier your graph has gotten. And then the last thing would be I will reflect them because a is negative. So these values would be down here at negative 12 and negative 3 and then 0. Now that I've done that, I'm going to shift every point up 4 units. So that means that this point will move up 4. 1, 2, 3, 4, right there. This point that was at negative 3 will now be at 1, and this point will also be at 1. And this point that was at negative 12 will be at negative 8. I'm guessing that they're going to cross again, but I'm not absolutely 100% confident in that because I don't have graph paper. But I'm thinking that they're crossing at something, comma, negative 8. Like this. So I believe, whoops, that's not a solution right here. I believe my solutions will be 1, 1. And let me see. So right here I'm at negative 2, so that's negative 5, 1, 2, 3, negative 8, comma 2. Negative 2, comma negative 8. Now I'm going to solve them algebraically. So to solve them algebraically, since I've got y equals and y equals, now I'll set them equal to each other. So negative 3x squared equals, plus 4, my bad, plus 4 equals 3x minus 2. I'll move everything one way, so I'll add 3x squared and I'll subtract 4. I'll add 3x squared and subtract 4. So I have 0 equals 3x squared plus 3x. That would be minus 6. Now the cool thing is, since they all have a common factor of 3, I can factor the 3 out and then divide by 3 to both sides. So x squared plus x minus 2 equals 0. And since I can see something that will multiply to 2 and add to 1, product is negative 2 and the sum is positive 1. It's 2 times negative 1, 2 plus negative 1. I know that, and there's no a, I know this factors really easily, so I'm going to factor it. 0 equals, since it's a is 1, I'm going to say x times x, and then 2 and negative 1 are my two numbers right there. Set each one equal to 0. X plus 2 equals 0. X minus 1 equals 0. So x equals negative 2. X equals positive 1. Boom and boom. Those are my x coordinates. And then I go back and substitute them in to find y. I'm going to substitute them in my original. 3x minus y equals 2. That's negative 6 minus y equals 2. I'll add 6 to both sides. Negative y equals 8. Y equals negative 8. So negative 2 comma negative 8. I'm not even going to check it. I already know it's correct. But you can check it back. And then the last one, if I substitute 1 into the original, 3 times 1 minus y equals 2. That's 3 minus y equals 2. Subtract 3. Negative y equals negative 1. Y equals 1. So my solutions are 1, 1, and negative 2, 8. Boom. Not too bad. All right, last one. So we read this one in class together. Go ahead, you can read it to yourself again. Really, this one is asking you to interpret the domain and range of the graphs. So the domain is your x values, and the range is your y values. So it really helps if you just watch how to find the domain. So the domain is from this to this value. Same, the domain is from this to, drop a line down, right? This value, but this one has an arrow, so it's going to be going on. And the domain, again, from here to here, but this one also has an arrow, so it's going to be going on. So for this graph, the graph stops right here. There was no arrow. So the domain is from 0. And we want to use a hard bracket, my bad. 0 up to, and then that would be 5 is our domain. Here the domain, it starts at 0, again, hard bracket. This time it's going on forever. We call that infinity, right? So it's going to the right forever. And since we never really reach infinity, we use a soft bracket. And this one, again, the domain is from 0, and it's going to the right forever because of that arrow, so it's to infinity. And this is, again, my domain. All right, the range. The range is your y values, so you look at the lowest and the highest point on your graph. So this graph goes from 0 up to 10 and then goes back down again, so 10 is the highest point. So this graph has a range of 0 to 10. This graph starts at 0 and it doesn't stop right here, right? It's going this direction, but it's doing that forever. So we'd say from 0 to infinity for our range. And this graph does not start at 0. It starts at 1 and it goes this direction, but it's doing that forever. So from 1 to infinity, and that is my range. All right, guys, I know that was a really long video. I hope that that made sense. We will have an assessment coming up. So you need to make sure that you're asking me questions if there's things that you don't understand. Have a fabulous day.